Okay, here's the second video on graphing inequalities. Okay, now we're going to talk about how to graph these inequalities and how to graph the ones that say maybe less than or greater than, or maybe it has a less than or equal sign. This is what it means, less than or equal, when it has a little bar on the bottom, or greater than or equal. Okay, so sometimes you'll see the inequality like that without the little line on the bottom, like these two, or sometimes you'll have it with the little line. All this means that it is equal to. Kind of like they didn't want to put two lines to make it look like an equal sign. Okay, so how to graph these? Okay, so what you're gonna have is, let's say for example, I'll put A, I'll put B, I'll put C, and let's just do some quick little XY axis. Okay, so on number one, we're going to graph. Now, for these inequalities, everything depends on the y. The y, or you're going to compare it to the y-axis. Everything's kind of in relation to the y-axis, right? And you'll see what I mean by that right now. So let's say, for example, if you graph, let's go back to just a regular equation. If we graph y is equal to 3. If we graph y is equal to 3, well, that means we go to 1, 2, 3. And this is simply, you know, this is not an inequality. This is just a nice solid line. A nice solid line. Here's y is equal to 3. It is the line that is a horizontal line. Nice solid horizontal line that is going through the number 3. Right? There's many points on this line. All these points are solutions. Okay? And that is the graph of the line y is equal to 3. We've learned those already. Now, what if you're going to graph y is greater than 3? And then what if you're going to graph over here on C, y is less than 3? Okay. So we're still going to kind of pretend like this is an equal sign. You're going to go to y, you're going to go to 3, just like we did over here. You're going to go 1, 2, 3. And there's more, right? 4, 4. You're going to go to y, you're going to graph y is 3. So again, it'll be a line like this on 3. But when it doesn't have the little, when it doesn't have this little line on it, it's not a solid line. It doesn't include the 3. It's like saying, pick a number greater than 3. Well, you can't pick 3, right? It has to be a number greater than 3, like 4 or 3.2 or something. It can't include the 3 because it doesn't have the little line in the bottom. So what you do is, since it doesn't include the 3, we kind of put like a dashed or like a broken line. So this is, you still graph the line y is 3, but it's kind of like a dashed line or a broken line. If it did have the little equal sign right here, then I would draw a nice solid line through that. But that's not all of it. You see, this is saying what? I want the values of y that are greater than 3. That's what this is saying. Y is a number that is greater than 3. So here's the number 3 where this line is, right? Where this dashed line, and here's the number 3. And again, you're just going to look at the y-axis because we're talking about just the y. Now, where are the values that are greater than 3? If here's my line, the values of y that are greater than 3 are either going to be above it or below it. Well, all the values that are greater than 3, like 4, 5, 6, are up here on this top side of this line. So these inequalities are actually shaded. We're going to shade the top part, because all the values of y that are greater than 3 are over here, right? 3.1, 3.5, 4, 5. See, this is the one where the shading means that any point or any value above this y is greater than 3 will satisfy the inequality. 4 is greater than 3, 5 is greater than 3, right? So it's going to require for you to do a shading. That's what indicates where all the solutions exist. Any solution that is up here, where the shaded area is, will satisfy this inequality. Like I said, there's an infinite numbers of solutions that you can put here. 6 is greater than 3, 7 is greater than 3. So we just shade everything above it. And the same thing over here is gonna apply, right? We're gonna go y is equal to 1, y is equal to 2, right? This is the y-axis, y is equal to 3. And you know what, for this one, let's put the equal sign on that one. So here, we're still gonna go to y is equal to 3, right? You don't have to read the inequality first. Just first graph the y is equal to 3, so that's this one. But it does have the equal sign. So when it does have the equal sign, it does include the 3. So we could put a nice solid line like that, going through 3. But now we're going to read this. So you have to know how to read it. If it's opening up to the y like this, kind of like a mouth, maybe some of you learned, that means this number's bigger. That means the values of y have to be bigger than 3. But if it's not opening up to the y and it's opening up to this other number, that means we always have to look at it with the perspective of the y. If y is not bigger, that means the values of y are less. Here's where the line is for y is 3, but where are all the values that are less than 3? You got to determine if it's above or below. Well, we know all the values of y. If this is the line 3, I want all the values of y that are 3 or less than it. So that's going to require for you to shade everything, including that line, because it does include the 3, and below it. So that's how you have to read these inequalities. Okay, let's try a couple more. Let's try number 1 over here. But now let's put something like y is less than 1/3 x plus 4. Okay, so I'm not going to worry about this right now. I want to make sure it's solved for y. I'm just going to look at the slope. And this is the y-intercept. So you're going to graph this just the way we graphed lines, right? We learned to graph lines, linear equations. And I know this is going to be a line, but see, it doesn't have that equal sign, so it's going to be a dashed line. It's going to be dashed. But let me graph a line lightly. So let me go to 4. 1, 2, 3, 4. So the y-intercept is 4. I put my dot there. And the slope is what? Rise 1 and run 3. Rise 1 and over 3 would be right here. Right? We learn to do slope. And I know I can keep picking points, up 1 over 3, up 1 over 3, but I honestly only need 2 points, right, to see where the line's going to be. And again, instead of drawing a nice solid line, right, this is going to be the line here. It doesn't have the equal sign, so it has to be a dashed line. It has to be a broken line because it doesn't include the 3. Now, we gotta look at this inequality with respect to the y-axis. Here's the y-axis. The y-axis is, there's part of the y-axis above it, and there's part of the y-axis below this line. Right? So I'm going to shade either the top or the bottom. Well, what does it say? I have to read this. Is this opening up to the y like that? Because if it is, that means that the values of y are greater. No, it's not. It doesn't mean that where this line is, the values of y that are greater would be above it. Right? So it's not. This is saying that the values where this line is, I want the values of y that are less. So obviously above will always be greater. All the values that are greater than where this line is are going to be above it. When it's less, when it's opening up to the, that means the values of y that are less are going to be the bottom part that you're going to shade. So here we're going to have to shade the, right, it's opening, it's saying I want the values of y that are less, right? So it's going to be the bottom half that you're going to shade. Okay, last one. Let's do one where we have to solve. Number 3. Is that number 2? That was number 1. Number 2. How about we have (8x minus 6y) is less than or equal to 12. Let's see here, we can't graph it yet. Remember, we have to solve for y. And remember, in the first video, we want this y to be positive. So actually, I don't want it to be negative. So I'm going to move this to that side where it makes the y positive. If I have to move that to that side to keep the y by itself, that means this one has to move that way. So what you're going to have now is this. This 8x is still here, 8x. And this positive 12 is over here positive. When you move it over to this side, it's going to be what? Negative 12. And this negative 6y, when you move it over to that side, it's going to be positive 6y. Okay, that's fine. Leave it like that. Again, we're not going to have to do that stuff where we switch the inequality. We're avoiding all that by doing it this way. Okay, now let me write it again. So that's going to be 8x minus 12 is less than or equal to 6y. We got to solve for y. Divide by 6. And everything gets divided by 6. All the terms. So now you're going to be left with this. Y is greater than or equal to, oh, did I forget something? Oh no, it's right here, x. 8 over 6x minus 12 divided by 6 is 2. But look at your slope. If you can always reduce, check to reduce, you reduce it. So that's going to be divided by 2, 4 over 3x minus 2. Okay, here it is. This is the one that I want. Leave it like that. Okay? Now, if you rewrite it, or if there's a choice for you to look at, maybe to select the correct equation, this is saying that y is greater than. See, it's opening up to the y. So if you were to rewrite it or compare it, it would have to be like this, right? Here's the y. Here over here is the 4/3 x minus 2. But here's the difference, see? This, I know it's facing this way, but so since I switch the sides, you have to keep this saying the same thing. This has to say that y is greater or equal to. So if I rewrite it, it actually looks different, and it would look like this. You see? But it's actually saying the same thing. So just in case if you compare, you got to make sure. See, this is opening up to the y and say then the y is greater, then you have to rewrite it this way. It's almost like if I tell you this. If I tell you, if we know that here's 5 and here's 1, and here's 1 and here's 5, we all know that 5 is greater than 1, right? So this one would have to be like this. See, that says 5 is greater than 1. Now when I switch the numbers the other way around, I can't write it the same way. You see, you can't write it like that. Then you're going to say that 1 is greater than 5. So you have to read it from the numbers and just know which one's bigger. If the 5 is bigger, well then the mouth is opening to the bigger part. And just because I switched, when I switch it, well then this also has to switch, see, because 5, see, these two are actually saying the same thing. They look different. This inequality is facing this way, this inequality is facing this way, but they're saying the same thing. So this one is saying 5 is greater than 1, which is the same as saying 1 is less than 5. But this one is also saying which one's greater? 5 is greater than 1. You see? So if you have to rewrite it, or if you compare it to an answer, but we don't need to do that. We can graph this. Okay, so quickly graphing this, -1, -2 is the intercept, is here at -2. You're going to go up 4, 1, 2, 3, 4, 1, 2, 3, 4, and over 3, 1, 2, 3. I'm just going to eyeball it, right? I went up 4 and I ran 3. And now you got to determine, is this going to be a solid line or a broken, or a broken dashed line? Well, this one does have the little bar, which means it is equal to. It is equal to, so it's a nice solid line. And now you have to read it. If the y is bigger, then from this line I pick all the numbers that are right. Here's the y-axis. You got to look at the y-axis. The values of y from compared to where this line is. Compared to where this line is, the values of y that are greater are above it. And compared to where this line is, the values of y that are less are below it. See, you're always comparing it to where the y-axis. So this is saying that I want the values of y that are greater, right? Because it's opening to it. So if the line's here, where are the values of y greater? Above or below? Well, here the values of y are increasing, right? +1, +2, +3, +4. The values of y that are getting higher or greater are always going to be above. The values of y that are getting less are always on the bottom. So this one is the values of y that are greater. Here's the line. Where are the values of y that are greater? Above it. So you shade. You're going to be shading this side. All right. Good luck with the assignment.